Hello everybody. We would like to now take this things one step further and consider the value of assets in a three-period world. All right, so three periods, and each of the future states have two contingencies, two states, two future states of the world, two future states in each future period, period. All right. One of the most popular models to handle these type of cases is known as the binomial tree model. Binomial. I think the name comes directly from the binomial distribution, which is really a where the name suggests binomial. So it comes from the expansion of an expression like a plus. For instance, if you were to expand an expression like this from your college algebra courses, this is a cubed plus 3a square b plus 3ab square plus b cubed. So there's a binomial process behind this thing which creates this equation, which you can easily confirm it algebraically. All right, so but back to our story. So our model will be the following. It will look like this. So this is today, time 0, t equals 0. And because there's an uncertainty about the future, so this is time 1. In time 1, what happens is there will be one of the following two states which will realize. This is time t equals 1. And then we yet have the third state, at time t equals 2, what will happen is, so whichever of the two states realized, for instance, if the upper node realized, then this will lead to two new states, versus if the lower node realized, this would lead to two new states. Do you guys see that? But in the end, because the middle two nodes are joining here, we ended up with three states of the world at time t equals 2. Do you guys see that? At times t equals 2, we have three future states of the world. Sometimes this is referred to as calibration. So we can calibrate our model, calibrate our model to make it more to make it able to handle more complicated situations. So I think the best way to handle this will be just to have a look at an example. All right, consider this multi-period world again. We will just focus on the binomial tree. It's a three-period world today and time 1 and time 2, basically, right? If you guys want, why don't we say it like this? I'm shooting the video sometime in mid 2020. So suppose that today time t0 is the year 2020, this year. Date is not important. t1 is 2021, next year, and t2 is 2022. And we have two securities, a stock which is currently selling at say $80, and a bond which is currently selling at say $60. Now, as it turns out, the bond values are fixed, so the bond pays 8% interest over time, and as a result we know exactly what the value of the bond will be at time 1. It's just 60 times 1 plus 0.08, which is 1.08. So 60 times 1.08 is $64.8. So we know exactly that the bond will be $64.80 a year later. And 2 years later, B2, you further multiply it by 1.08, and the stock will be, the bond will be worth $69.98. And it's very easy to, using a calculator, do that. Now for the case of stocks, it will be a little bit different. So the stock as 0 was 80, remember? So the stock will have one of two future prices. So in the it will either be at time 1, the value of the stock. Let me just remove that. So all this is the stock. So this is how we can model the stock. Either the stock price a year later, in the first state, either it will be $105, or in the second state, it can go down in value and it can be $70. However, 2 years later, 2 years from today, what can happen is the stock prices will further progress, right? So what will happen is the stock price, if it takes that path, this upper path, it will further go up to $130. Let me write this again. Or after taking the up path here, the state one at time 1, as it moves to the next period. So remember that the dates were, let me just put down the dates. So this is actually, let's write it like this. So this is 2020, and this is the future, which is uncertain, and we are trying to model it, make some forecasting and prediction, right? 2021. Now we need to go one step further, and we want to predict 2 years into the future, right? That's the whole point. 2020. All right, so going back to our model. So let's say that the assumption is that it will be 90 here, or like one good year followed by one bad year, or one bad year followed by one good year, you can imagine. And then if 2 back-to-back bad years happen to that stock, the value of the stock goes down, and then it further goes down. Do you guys see that? Here it goes up in value, and then up in value, or up, down. Even up, down is good. The stock price went up, right? Because it started at 80. After an up, down, it is 90. Versus a down and up, again, is a good thing for the stock. So as long as you don't have 2 downs in a row, the stock price will go up in value. But the one which goes the most up is if you have 2 ups in a row, right? So we will end up with one of 4 paths. The paths available to us, the paths available to us is either up and up, after which the stock price will be $130, or it will be up and down, or down and up. It turns out the order does not matter, it is $90. Or what if we are in a case where it is down and down, then the stock price, it goes down to $60. Now, given this structure, this model, now what we want to do is we want to value yet a third asset. All right, the third asset that we want to value is a call option. Based on all these givens, what is question, what is the value of a bond, sorry, not a bond, a call option, I should say, a call option with maturity 2022. This option will expire in 2022. You can only exercise it in the year 2022. In that sense, it's a European call option with a strike price. Some textbooks call this strike price with the letter X. Some textbooks call it with the letter K. Doesn't matter. Let's call it X, for instance. With strike price $80. That's exactly what we want to calculate. We want to calculate the value of this call option, which promises, which you can exercise at the end of year 2022, I should say, 2 years later, with a strike price of $80. So 2 years later, if we are in one of these 2 states of the world, then we can exercise our right to buy the security at $80, and we can end up selling it at 130 or 90, and we make a good profit out of it. I think it's clear. The outcome is clear. And if the only case where we will end up this call option will go worthless is this one. If 2 downs back to back, the call option will go worthless. So then the question is, how much is this call option worth? And you guys can imagine, again, we will use the linear algebra, the systems of equations solutions, to solving this problem. But what we need to do is we need to first create the state contingent claims. All right, so the prices, we need to calculate the prices of state contingent claims at each state. All right, so and for that, what I will do is the standard method to solve these type of multi-period questions is to go backwards. You can call it backwards induction. All right, so the way I will do it is the following. And I argue this is the simplest way of doing it. There might be some other ways, but this way really works nicely. I can just focus on this simpler problem. Start here, and this will lead us to either this point or this point. So what I will do is I will pretend that I'm at that point state. If I were at that state in year 2021, what can happen? So I can either end up at 130 or 90. So why don't we just construct the state prices for these two situations? All right, when I say state prices, I mean state contingent claims, the prices of the state contingent claims. What if after I ended up at this point, after an up move, let's say, then what are the prices of each of these state contingent claims, which further gives me this much or this much in those individual states. All right, so what we can do is we can set up our equations as usual. So let me just move that thing to the right, and let's construct these state contingent prices. So I know exactly the way it will progress, right? I know how the bond prices progress as I go from one state to the next. So the first one is the first of the equations will come out from the bond, and the second one we can bring it out from the stock. So the first of the equations will be such that the bond is worth, all right, so it will be the following. So the bond currently is selling, well, at the end of year one it will be selling at 64.80 with certainty. So 64.80 is equal to, so we need to get 130 state contingent claims, which will end up at up, right? So let's just call it PUU if you want. How many of them? 130 of them. Okay, let me write the number first. 130 PUU plus 90 PUD. Do you guys see that? And for the stock, now this is the interesting part. So for the I should say, yes, for the stock, the way it will happen is the stock price is currently $105 at the end of year 2021. So $105, and that thing is equal to, it will, oh, sorry, what did I do? The first one was, I just looked at, I was supposed to do the bond for the first one. Okay, so the first one was the stock, what I did, sorry for that. All right, let me do the bond right now. Oh, my bad. All right, sorry for that. So in the case of bonds, this one is 64.80. All right, there you go. And now, regardless of the state where you're in, it always gives you 69.98. So 69.98 PUU plus 69.98 PUD, right? So PUD. That's it. So what we can do is we can solve this system of equations for PUU and PUD. And let me just go ahead and, you know what? Let me just pause the video right here. You guys can know how to solve it using Excel. I'll just do the solution on Excel, and then I will copy the numbers over here. So let me just pause it right now. All right, so I did the calculations in Excel, and my numbers came out as 54 cents for the first one, and actually I can be even more precise. So it came out as, oops, 0.58, sorry, 54.15, I should say, 54 cents and more, 54.18. All right, to be more precise. And for the second one, it came out as 0.3844. 0.3844. There you go. All right, we'll pretty much do the same thing for the bottom half. So basically, let me just go ahead and highlight it. So we'll starting from here, we can either take the path up or we can take the path down. Do you guys see? And those two overlap somewhere in the middle, right? So we can clearly see that. Now let's go ahead and do the calculation for those two. I can directly start with the stock, I guess. So $70 worth today, the stock. And in the future, it is equivalent to 90 state UD contingent claims, or DU, doesn't matter. Well, DU and UD are the same. I'll just keep it, or okay, let's just write DU so that it's no confusion, because the numbers will come out differently. That's right, sorry for that. Plus 60 DD, PDD. And the bond, which will be valued at 64.80 in the previous period, will still be worth the same amount. So 69.98 PDU plus again 69.98 PDD. All right. So yes. So now we can go ahead and solve them simultaneously again. So therefore, three dots arranged like that means therefore in math. Okay. Therefore, PDU, we need to calculate that, and then we will also calculate PDD. These are the state contingent claims, the prices of state contingent claims in the year 2022, assuming that the following state happened in the year 2021 and so on. All right, so let me just go ahead and do it in Excel, I guess. There we go. Let me just let me just pause the video again. Okay, so I finished it again, and my state contingent claims came out as PDU came out as 0.4814. Oops, come on, 0.4814, and for the down case, the state contingent claim is worth $0.4446. There you go. And let me just go ahead and highlight these values. So this is the PUU, this is PUD, and for the other two cases are like this. Now remember what we said earlier, we are going backwards induction. So now from 2022 we came back to 2021, and now what we can do is we can go ahead and calculate the price of the call option, which if the call option started at year 2021 and expired in 2022, a 1-year call option, which started hypothetically at that point, what would have been the value of that call option, the price, and what would have been the value of the call option if it started over here, right? So if the call option started on the over here when the price of the stock has $105 in 2021, hypothetically, if it were, then what would be the outcome? Because we know that the state contingent claims are priced as such, all we do is look at the outcome, $130 and $90, the resulting two outcomes, if we started at that point at where the stock in 2021 is $105. So the value of the call option, because the call option has a strike of I think we said what is the value of a call option, maturity in 2021 and strike of $80. So the call option at that date, we don't know what is the price right here. That's what the question is asking. But what I will do is I will calculate the price of the call option if we ended up at that point versus if we ended up at that point. If this point realized, what would have been the value of the call option, for how much price the owner of the call option can sell it for, right? That's what we are doing right now. And the value of the call option in that case would have been, well, because if this state realized 130, because the call option has a strike price of $80, it will have a $50 payout, 50 times the state contingent claim, which is PUU, plus, or if we ended up at this state, assuming we started with 105, because the strike is $80, the difference is $10, and 90 is more than 80, so 10 times PUD. You guys see that? And all I do is just to plug in these values of PUU into right here, and then this value of PUD into right here, and then calculate the value of the call option. So I have a calculator in front of me. Let me just do it right away. So it is 50 times 0.5418 equals plus, I got 27.09 for the first one. Let me do it in 2 steps. 09 plus the second one is, well, 10 times this number is obviously 3.84, I guess. 3.84, and adding these two, the value of the call option 3.84 plus 27.09 equals $30 and $30.93. So this call option is worth $30.93 if we ended up at that node over here. At that point, that's the value of the call option. Now, what is the value of the call option if we ended up at that 70 point? Well, it's a risky option then. Either the stock price will go up to 90, at which point the call is worth $10, or the stock price will go down to 60, after which the call option will go worthless because the strike price is $80 above $60, right? So therefore the call option there will be the following at the lower end. So I can call it CU and CD if you want. CD is the value of the call option right here. So CU is right here and CD is C sub D is right here. So CD is $10. $10 if we ended up at that state, and we need to purchase this many state contingent claims of DU, not UU, DU now, right? So DU versus $0, 0 units of DD basically. That's it. So it's just 10 times, because 0 times this one will just vanish, 10 times this number, which is $4.81. Now we can combine them together, go one step backwards, backward induction. So therefore, what is the value of the call option? So what we need is, we need to further calculate state contingent claims for going from here up versus down. We need 2 sets of new equations for that. So let's do the very last step and let's finish it with this question. So first, we need to calculate the state contingent claim, which will, starting at year 2020. In year 2021, what happens if we end up at that point, or what happens if we end up at that point, right? So if we end up at the up node, 105, let me just do it, I guess. So right now the price is $80. I'm doing the stock first. Oops, sorry for that. $80 is equal to, well, 105 P, let's call it just U now, and or alternatively 70 PD. That's it. How about the bond? The bond, remember that it had a value today of $60, and in year 1 it will have a certain value of 64.80. So 60 is equal to 64.8, regardless of which of the 2 states happen. It will always give you 64.8 PD. That's it. And so given these 2 equations, I need to first solve it for the state contingent claims in year 2021, PU and PD. Let me quickly calculate them using my Excel. Actually, I have Excel open in somewhere else. So I'll just go ahead and enter the new numbers, 105 and 70. And these 2 are 64.8 and 64.8. All right. And the values are 80 and 60. 80 and 60. All right, so I got my numbers as 0.4339, 0.4339. So this is the price, obviously. Maybe I should put a $sign over there somewhere. This is equal to $sign. And this one is $sign 0.4921. 0.4921, 49.21 cents if you want. But now that I have the values of these state contingent claims, we can finally find the value of the call option at that date, at date 0 if you want, in 2020. What is it equal to? Well, it will be, because starting from this point, we will end up either here or here, and we know those state contingent claims, what are those values, right? So they are right here. So if you want, let me just color code it like I did earlier. So starting from this path, we can either go up to that path or go down to that path, and we calculated the state contingent claim prices for those two states. So finally, as a result, the value of the call option, let's do it here. So the call option will be worth equal to, if we end up in the up value, the up is 30.93, 30.93 PU plus, or we will end up at the down, at which point the call is worth only 4.81 PD. And it's now very easy business. So just multiply 30.93 with this number, and then add to that 4.81 times this number. So I have a calculator in front of me. Let me just do it, and let's finish with this question. 30.93 times 0.4339. That one is 13.42, 13.42, plus the second one is 4.81 times PD is 0.49, 21. That one is 2.37, 2.37, and lastly, this is equal to, adding them, 13.42, 15.79, $15.79. I think this kind of gives you a good idea of how models, asset pricing models work in real life. So now you can imagine financial institutions, hedge funds, investment funds, or investment banks building these call option pricing models to price securities. But ultimately, the key idea is, if you have a multi-period model, is to break it into smaller pieces and start from the back all the way to the end, the final year. In our example, it was 2022, because this call option was maturing in 2022, and we were able to working our way backwards to value the security and figure out what is the value of this call option, which expires in 2 years, which have this property of $80 strike price. And this value came out as $15.17 in the year 2020. So this security should sell at that price. Hope you enjoyed this video, and looking forward to see you guys in our next lecture.